Well, welcome back. For this part here, we made in previous tutorial a beam, a simple beam, a T-cross section. And now we plan to do a couple of simulation, finite element simulation. Again, this is an example. The component can be any complex component. This is just an example I want to show you, but the principle will be the same. And this component that we made, again, we use parameters to model it. It means you can come back and modify things after you've done the simulation. And let's say you realize that these slot here, or maybe these holes here, you need to adjust the size. You can simply go at the bottom here. As you see, you can change things. Let's say if I select this sketch, I can change the diameter here from 35 to whatever number that I want, and the model automatically will update. So then automatically I can see the result on the simulation. That's the good things. All right, now from the design space, workspace, we are going to move to the simulation workspace. So on the top left corner, when I click on that drop down arrow, we'll see here simulation. So click on simulation and you'll see a new window pops up. It says new study. So we have several studies here. Static stress, we'll use it a lot. Some teams, if they are dealing with a component that deals with vibration, loads, so the modal frequency will be useful. Buckling, perhaps, if you have a component which is going to be under buckling. Thermal or thermal stress as well. And we will explore today static stress, thermal stress, and shape optimization. There are like dynamic events and so on, which you can also explore on your own later. But let's just do a simple static stress analysis. Click on that one and you create a study. Right? Now I'm in a different environment. I can close this window here on the right. Okay. So here is my structure. It's very easy to conduct the study here. First step is material. You click on the material, study material. What is the material you have here? Is it by default, Fusion choose steel, which you can click on property and you see the property of a steel. Right? So if you click on the property here, but you can change it to any material that you want. And so rather than same as model, I'm gonna select, let's say for this study, aluminum 75. Today, let's call it the aluminum day. And now you can look at the property of aluminum. You can have your own material actually by modifying those numbers. That's all that possible. And then select. Okay. So our material is aluminum. And then the next step, this beam, of course, is not on the air. It's been connected to somewhere. And maybe it's a cantilever beam. So I need to select the constraints. So structural constraint here on this icon here on the top. I click on that one. And let's say this beam is being fixed on this side. I select this side. You see a little lock sign appear there. Okay. And now it's fixed on X, Y, Z direction here on this little window. If you can see it on this face, UX, UY, UZ, it's being fixed. So I click OK, and it's been fixed, and this is the sign that I see there. So this is the beam that we have. Let's say it is on a simple single load, structure load on the other side of this free end of the beam. So I select the edge. Do not select the corner here unless your load is really on the corner. But if you want your load to be on right in the middle, select the edge. And when you're selecting the edge, so you can have the force in X, Y, Z, but for simplicity, let's say I have only a force of 1,250 or 1,000, just an arbitrary number. for the sake of discussion, and negative because I want it to be down, following the XYZ coordinate that you see on the right top corner here, right? So 1,250 Newton load on here. And then you can change your unit again if you want, or adjust the unit as you wish. But we are on Newton and we'll stay with that. So we got the load, everything is being set up. And now all I need to do is just asking the software to do the simulation. I click on, let's say solve. If this pre-check is green, it means everything is good. Later, I will talk about more on setting up the mesh size and its effect. But for now, let's say, solve it for me. And so the software uses its default or the optimum mesh size to solve it. So click on solve. This window will pop up. And here, please listen carefully, because many of you are going to have trouble here. See, okay, after clicking that, nothing appeared here. So you see on my window, it shows that your account does not have enough credit. Okay. So intentionally, I did that because it happens to you what you need to know. So keep in mind, if your license is education license, this one should not appear here. But if in case it appeared, click on this arrow here on the top and show the cloud credit cost and balances. See, I click here. And now I say, okay, manage my account, because I want to know what's going on. And this window pops up. Perhaps I have two accounts here, and that's one of my account. Maybe I didn't pay and I don't have enough credit. So as you see, I have two accounts, but the education one, when I click education account, which is the one that you have, and click OK, then you see here this account education appear, and you see available credit unlimited. It means you can do whatever simulation you want to do, and it's unlimited, which is a good thing. Later, after you graduate, you go to industry, you will see the value of that, because you see for each simulation, perhaps you need to pay some money. But for now, it's free. So make sure that then education is here, and this is unlimited. It means you are good to go. And then you say, solve one study. And give it again a couple of seconds, more than a couple of seconds. So it's thinking, and now you'll see this pops up here, and it's doing the study for us. So if the other things is the things that I've done before to do the test and make sure things are working, but this static stress, it shows 5% progress, 7%. It takes about maybe 30 seconds for the result to appear. While it's thinking, you can close it and do other things. It allows you to do other things, go to a different file. All right, rather than waiting, I'm just going to go to the simulation that we've done before, that I've done before, and the result is ready. So here is the result that you will see after the simulation is being done, which will go back to the beam that we created, and we'll see that one as well. So what you see here, again, is the same beam. We apply the load as we expected. Here is a cantilever beam, and here is the deflection here. On the bottom here, you see it shows the safety factor. And if you see this drop-down menu here, you can see you can change from stress, safety factor to a stress, and so on. If you don't see this drop-down menu, right? If you don't see that one, if you recall, we changed something on preference in previous section. So all you need to do, if you forgot to do that, go to that top icon here when you see your name, click on it, preference, and then here when you see on the left preview feature, click on preview feature. Here you should see something says simulation, and uncheck the new experience, which we uncheck it, so that's why we don't see it here. So it shows me the safety factor, right? The safety factor, you see the number from 0 to 8, and it shows it by color. So wherever it's blue, it means my safety factor or factor of safety is between 6 to 8, so the blue area. And the green area, it's the factor of safety is between 3 to 6, which is good. And there is no red area. So for this simple design, we don't have any area with factor of safety below 1, because below 1 means failure. But if we have 1, we can go back and modify our design and make changes. All right. So if, and what else we can do here is factor of safety. Click on stress. I'll get back and answer your question shortly. For now, just listen, see what you can see. Here you see the stress. So, and you can analyze different part for stress. And obviously at the bottom here, when it is red, you have more stresses. You can also inspect the particular point for stress. For example, asking to show you the minimum and maximum. So this is the maximum stress that's happening on at the bottom of these hole here, close to the support, as we expect. Perhaps there's a little bit of stress concentration. You can check, check the stress at different area by probing it. So we can explore different inspection here. Create surface probe. Let's say I'm very interested to know the amount of stress at this particular point. You see, when I hover my mouse there, it shows the stress. I click on that one and it shows the stress there. Let's say when I want to make a report, I want to create those probes, I can do that. And then I click enter. So I have those probes. So this is the stress here, there, and so on. So the stress, the unit is in megapascal. You can change it. And the value of stress at the bottom here on these actually bar that you see is 1 Mises stress. 1 Mises stress is the main, it's sort of a common method for showing stress, but you can change it to normal stress, principal stress, or shear stress, but stay with 1 Mises stress. Most of the industrial report, people stay with 1 Mises stress. You can switch from stress to displacement to look at the displacement and see where the maximum displacement happens. Of course, it's a cantilever beam and it's obvious how the displacement happens. Just for the sake of show, here on the top, you can go to the deformation, and sometimes on this case it's obvious if say that just adjust it to 2x. It is again is for the visual. So you say really where the maximum happens, right? The formation adjust it to an actual one. So this is the actual displacement, which is very, very little, right? For this beam, this is the actual displacement, the deformation or deformation. This is the actual. If I say adjust, adjust means that for the sake of visual, the program adjusts it to something like maybe 1.5 times larger or 2 times larger or something like that. If you are making a report for your client and you want to show them a simulation, especially if it's a complex part, you can make a video actually of this deformation. Click on that little camera or animate that you see here on top, left, and then this window pops up. You can click on two-way. You can select the steps and other things, click on record. For now, let's just click play. So this is how it deforms. You can rotate it. So it shows you how it deforms, right? And now when you are satisfied with the view and everything, you can record it, and it's record a file for you on your computer. It takes a few seconds, which I'm going to avoid and move on to the next step. Okay, you can do it for displacement, or you can again from this drop down menu, you can do it for stress as well. So it shows stress. So you can see at the bottom where the stress is maximum. And here, click OK. So we're done with our analysis here. And when we're done, we can click Finish Result. So we're back to this one. Let's go back to the one that we've just completed, a beam. So here you see the same things appear here. You can close it and the same number, the same everything. If you don't see that one, or if you said click on Finish Result and you wish to come back to the result view, all you need to do is just double click on the result. And you're back to the result view. So this is factor of safety, this is stress, and so on. Okay, I'm gonna stop the record here so you can ask your question. So let me just say cancel. Sorry, say it again. Stop recording.